All right, increasing, decreasing, and stationary. So let's say that we have a function that's drawn up as a graph, and it's defined at x is equal to a when f dash of a, so the derivative at that point is also defined. Then we've got three different definitions that we can talk about when we are referring to the graph, okay? So if we have the derivative at that point, so if f dash of a is positive, then what we can say about the graph is that the graph is called increasing. So the graph is, I should say graph is, not just is. And a graph is said to be called increasing, or we can say a graph is increasing, okay? So if the derivative at that point, okay, so if you're doing the derivative of a line and all your tangents are positive, then the graph is said to be increasing. Okay, the second one is if it is negative. Okay, so if the derivative, if you look at your gradients and the gradients are all negative, okay, then the graph is said to be decreasing. Okay, and then the third thing is if this derivative is 0. Okay, so it's a flat horizontal line, then the graph is stationary. Okay, and we can use those definitions of increasing, decreasing, and stationary to talk about different types of graphs. And so let's do so in the first example that I've got, or the second example I've got lined up. Okay, so a particle is moving in a vertical line. The graph shows the displacement, so like the distance from a particular starting point, of the particle after t seconds. Okay, so when is the where is the particle meet the maximum? Okay, so let's have a look at this particle here. So like it's a point, it's moving in a vertical line, so it's basically moving up and down. So basically it starts at this point. Whoop, go away, go away, go away, thank you. It starts at this specific point, let's say it starts down here, okay, and it's already started, so like when they took the snapshot, it's already moving. Okay, so it moves up, it moves up, it moves up, okay, and that's what this is here. So it's moving heaps far up. Okay, then it gets to a point, and then it's going to start coming back down. Okay, so it starts coming back down, starts coming back down, starts coming back down, starts coming back down until it gets here. And then it's going to keep going backwards for a little bit. Okay, which is this bit here. Then it's going to turn back around. Okay, and after a few seconds, or a bit of a second, it's going to end up about there. Okay, so that's basically what this point is doing. What we're going to be looking at is how quickly is it actually doing those movements. Okay, so let me just erase this. Okay, so when did the particle meet its maximum? So when was it at its highest point, or at its furthest, at its highest point, because it's a vertical line. When was it at its highest point? Well, it's pretty easy. It was at its highest point when t was equal to 1. Okay, so it was at its maximum when t is equal to 1. When was the particle increasing most rapidly? Okay, so that is essentially in this case, when was the particle, like when was it going up? Okay, so when was it increasing most rapidly? So let's have a look at all the tangents. So between 0 and 1, all our tangents are positive tangents, so it's increasing at that point there. Then it gets to the point at 1 where it's flat. Okay, so that means it's going to be a stationary point where it stops, and then it's going to start coming back down at this point here. So all the tangents along here are negative, okay? And they're still negative all the way until they get to 4, okay? And then when they get to 4 seconds, they're going to stop again, and then it's going to start increasing and increasing and increasing again at that point here. So I'm going to say it's increasing, okay, at when t is between 0 and 1, not including the 1, because then it gets stationary at 1. So it's stationary at 1. Okay, then it's going to be turning back down again, so it's going to be decreasing, so decreasing at, okay, so it's between 1 and it's going to keep decreasing until it gets to 4. So it decreases until it gets to 4, but it doesn't include 1 or 4, okay, because it's stationary at those 2 points. Gets stationary again at 4, so stationary at t is equal to 4. Okay, and then it's going to continue back up again when it's greater than 4. So increasing at t is greater than or not equal to, you gotta stop doing that, when t is greater than 4. Okay, so increasing between 0 and 1. Okay, so because all the gradients are increasing, it's flat at 1, so it's stationary. It's decreasing between 1 and 4, flat at 4, and then increasing when it's bigger than 4. Okay, so all of these, even though it's almost flat, they're going to all be flat all the way around. Okay, so we'll get rid of those. All right, sketch the graph of dA dt at which the particle is changing. So basically what we're going to be doing is we're actually going to be graphing what the derivative looks like in this case, okay? So the derivative, I'm going to start off by making up a Cartesian plane like this. So what we're going to be essentially doing is we're going to be looking at all the individual points, okay? And trying to sort of guess or estimate what we expect the tangent to be, the gradient of the tangent at each of those individual points to be, okay? So the easiest ones we're going to start off with is, well, let's first off by putting all our t values in. Now, our y values or our vertical values are going to be different, okay? So the horizontal values will stay the same. They'll all be 1 through to 5, or 0 through to 5, I should say. But then our values at each, going up and down on the displacement side, or in this case, our derivative side. So this will be dt for derivative of the displacement with respect to time. Okay, I don't know why I have dA dt there, but it's dd dt. So looking at this, we've got, so let's start off, let's start off with the easy ones. When is the derivative equal to 0? Well, it's at 1 and 4. So that basically means that the graph of my derivative is going to go through 0 at 1 and 4. We're essentially saying, what are the values of my derivative, okay? And I guess you could sort of put a table of values if you wanted to make a quick sort of easy guide on what to do. But we can see that we've got a horizontal flat line and another horizontal flat line at 1 and 4, okay? So the derivative at those 2 points is equal to 0. So when I'm going to graph the derivative, okay, at the points 1 and 4, my point will be when dt is at 0, okay? Now, looking at the left side of the 1, okay, we've got an increasing function, and it's slowly starting to get shallower and shallower. So if I was to just draw a couple of lines, okay, so it starts off a bit steep, and then it comes back around, and it's getting shallower and shallower and shallower and shallower. So it starts off as a high value, so a very high gradient value, and it's getting shallower and shallower and shallower and shallower like that, and then it gets to 0. Okay, then when it gets to 0, my gradient starts getting steeper and steeper and steeper, but in the negative direction. So it starts getting steeper and steeper and steeper in the negative direction. And between 1 and 2, okay, is when it starts to decrease at its biggest rate. So 1 and 2, it starts to go down like this. Okay. Then after 2 seconds, after t is equal to 2, our gradient's still negative, but it starts to get shallower and shallower again. So it's starting to come back after 2 and starting to get closer and closer and closer and closer again and go back up towards 4. Okay, because as you can see, it's sort of this point here where my graph starts going from steeper to being back shallower. Okay, and it's going to do that all the way till we get to 4. And so you can see that value, it's going to come back around and get closer and closer and closer to 0 as we get to 4. Then once we go past 4, it's just going to be increasing all the way back up. So it's going to go back like this. And this turns out, it's what our gradient, what our derivative function will look like. So these are basically telling us, okay, at this point here and this point here, our derivative is increasing. Okay, as this point down here, our derivative is decreasing, okay? Okay, so it's still a negative, like the gradient values are still negative down here and positive up the top, but these are giving us actual values for these things here, okay? Now the last question, when was the rate of change decreasing and when was it increasing? So when was the rate of change decreasing? So we're looking at this function now, okay, so this one down here, and we're going to just do the same thing as we did before. When is it decreasing? When is it increasing? So it's decreasing, so my tangent values are all negative between 0 and 2. So it's decreasing, and this is part D. It's decreasing when t is between 0, including 0, but not including 2, 2. When it gets to 2, it's flat. So it's in fact stationary when t is equal to 2, okay? And then after the 2, well, you can see that now it's all increasing. So my function is increasing when t is greater than 2. And every single value of that. So all of the derivative function, it's all increasing from that point there, okay? So with that being said, that was probably the trickiest one, and probably the trickiest thing that we're almost going to do in this whole topic is this second bit down here. But with that being said, that's pretty much the end of this, okay? And that's going to end us on this beginning of the week, so the rates of change. So that's going to finish us off with the rates of change. And then in the next one, we're going to have a look at the continuity of a function.